Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today with some really interesting information, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it again later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for one of our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's presentation and go over those questions. And finally, we are going to be doing a drawing for 3 $50 Amazon gift cards. It's a totally random drawing, so stick around until the end of today's presentation, and we'll be doing that drawing for those 3 lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is AIOps, your DevOps co-pilot. And today's webinar is, as I said, all about AIOps. And so I wonder, do you feel like you're lost in the fog of system development? I know developers' lives got tougher between 2008 and 2019, and there's just too much to grok. So you do need a co-pilot. So this webinar, we're going to be talking about how to understand why AI and ML is so well suited to IT ops and DevOps. We'll also be talking about why you don't need to know how to run ML to get the value of AI ops. And our speakers today are going to be covering some specific lessons that include what is AI ops, measuring AI ops, where AI ops offers a return on investment, and also offer up a guide for assessing where to automate. So our speakers today are Marco Coulter and Ravi Lachhman. Both are technology evangelists with AppDynamics. Marco is the tech evangelist for the analytics and business intelligence at AppDynamics, and he's a former startup CTO. He has progressed from operator to leadership roles at CSC, CA Technologies, and 451 Research, where he led the data sciences organization. He earned the nickname the Tech Whisperer for his skills in translating technical concepts for business leaders. Marco, give us a wave. Welcome to today's program. Our other panelist today is Ravi Lachhman, who is also, as I said, an evangelist at AppDynamics, and he focuses on the cloud and DevOps spaces. And before he joined AppDynamics, he spent time at Mesosphere, Red Hat, and IBM, helping enterprises and the federal sector design the next generation of distributed platforms. And when he's not doing the technology gig, he enjoys traveling and traveling the world, especially with his stomach. Ravi, thank you for joining me. Awesome. Well, gentlemen, thank you for joining me. I want to go ahead and turn things over to you guys. So I'm going to put myself on mute, take myself off screen, and let you guys get to it.
Sure. Thanks, Charlene.
Oh, great.
Well, thank you, everybody, for attending the webinar today. We have a pretty jam-packed agenda, so buckle up for it. Before we get into AIOps, actually, we're going to be level setting, or Marco is going to be level setting on what artificial intelligence is. After that level set, I'll be going and talking about reliability, how that bodes to systems that we might interact with today, and actually things that we might be doing that we don't even know have this type of reliability and AI behind it. After that, Marco is going to dig into why AIOps, and also the AppDynamics and Cisco stance behind the Ops central nervous system around AIOps. After that, I'll be talking about how, as engineers, we can actually enhance ourselves with our jobs and our work with AIOps. And then finally, Mark is going to take the lead on where do we actually get started with this new term, AIOps. So Marco, I think we have a poll question before we get started.
Okay, we're going to be pushing out the first poll question now. The question is, have you personally trained a machine learning model? It's stupid simple, yes or no. We'll give you guys a couple seconds to make your decision. And while we are waiting for everybody to vote, do want to remind the audience that at any time during today's presentation, you have the opportunity to submit your question that you may have for Marco or for Ravi. So you don't need to wait until we get into the Q&A section. Okay, we've got just a couple seconds left for today's poll. It's the first of 5 polls, so lots of fun there.
We'd
So
love
I'm going
to
to go
learn from our
ahead.
attendees.
Yeah, we want to know what everybody thinks, but
Yeah.
this particular one is really just to assess the audience. I find in developer audiences, when I'm speaking at conferences and so on, there's a lot of people who've never actually done this, and that's why I like to do this level set that's coming up.
All right, great. Well, I'm going to go ahead and close it right now so we can take a look at the results. Whoops, where'd it go? There we go. It's like the majority of folks have not personally trained a machine learning model.
And that's exactly what I see, as I say, in the audiences across the country. So for the 14% who have, please bear with me for the next few slides. I'm going to oversimplify to explain what machine learning exactly is. If we come back to the presentation, so very quickly, let's talk about machine learning. We've all seen the movies, they're out there, sort of thing. This is from Ex Machina, where robots are, indistinguishable from humans. They speak like us, they act like us, and we can't tell the difference. In the trade, we call that artificial general intelligence. It doesn't exist today. I'm happy to have a debate with folks over time whether it will exist over time. This is where we are today with machine learning. This is a Boston Dynamics robot. It was taught to turn the handle and open a door. It wasn't taught what to do if the door was already open. So I put this in here to sort of level set us of 2 key lessons from this. One, it's always funny watching robots fall over. And then the second one is just that if you don't, machine learning will not identify for you when you haven't taught it about something, when you haven't taught it about how to, that the door could be already open. And that's sort of where we are with machine learning. The metrics are very good, but the lessons require more. So let's examine what machine learning does for us in programming. If you think of traditional programming, there is an argument that says that the traditional programs you write are some form of artificial intelligence. But today what we used to, our traditional model is we take live data in, we write a program. That program has case statements, if then else statements, different things for assessing and comparing the data, and it produces an output of the decision that we're looking for, the outcome that we want. If we look at machine learning, we get it's a different approach, that we take training data and we feed that into the machine learning, the model that we're trying to create, and the output is not the decision, it is a program in itself. It is the model that will then feed live data into, and it will then produce the decided output, the outcome that we're looking for. So that's a sort of high level understanding. So let's step through an example, just a very, very simple example. If we just look at linear regression, right? Y equals A plus BX. Yes, this is the basic linear regression that you use in your Excel or spreadsheet programs. And what I'm going to do here is just quickly step through some code to show you training a model to predict the selling price of a home in San Francisco, based on the various data we have from prior sales of homes in San Francisco. Let's get some terminology down first. Simple spreadsheet in data science, I refer to the columns, there's different types of data as features. You see some people also call them attributes or predictors. And then each row in the data set is called an instance. Other people call them observations and records. And then the thing we're trying to get to, that is the objective or target. So you'll hear me refer to them as feature, instant, and target. And objective. So now let's look at some code. I would normally run this live. We're doing this as a webinar. I don't want to chew up the network, so I've got screenshots here for you. I'm using a Jupyter notebook here, so we're working in Python, and I'm using Pandas as the analysis library. Pandas is easy to use, and it avoids us having to switch over to R for analysis and modeling. It's good enough for linear regression. For more complex needs, you might be looking at scikit-learn or stats model. I'm also pulling a NumPy here to give us large array and some other math functions. So what we do is we read the data in first from a CSV file into what Pandas calls a data frame, which is essentially Pandas's spreadsheet. The next step is that we prepare the data, normally a job for the data engineer, by losing the features or columns that are not important to us. So you could load in all of these columns, but if you do that, the training of the model will take longer. So you start to identify the columns that actually influence the outcome. Clearing out features will help the training, the model training run faster. Now that we've sort of cleaned our data, the first thing we want to do is understand which features correlate to the outcome that we're looking for, the target that we're looking for. So we run our first correlation run to identify the feature that will work best as the X value for linear regression. This identifies the feature that seems to have the best relationship to our target feature of price last sold. So of course, price last sold on this list gets a value of 1 because it's a direct correlation, and it is the target value. But what we see here is that square footage seems to have the highest value in terms of correlation to the value, to what we're trying to seek out. So now that we have the X, we need our A and B. So let's just pick that top correlated feature, and now we're going to start training the model, and that will calculate these values of A and B. And then training the model, we split the source data set into 2, one for training and one for testing the model. Here I'm holding back about 30%. You see a test size of 0.3 in that top line. I'm holding back 30% of the data. You can't test and train with the same data or else it's not a test. So we train the model here, and then we test the model, and then we have our outcome. So with that, I like to always visualize where I can. So here I'm importing Matplotlib to draw the diagram here. But on the next slide, we'll see the actual chart. So the original data gets shown in all these dots, and we get a simple linear regression blue line through there of predicting. And now we can feed in the finished square footage and predict the probable price. So that was an incredibly simple example, and the data scientists on the call will be sort of losing their mind at how simplistic it is. When you get into nested neural networks and image recognition and so on, it's a much more complicated scenario. But again, I wanted to just show you that training the model is easy. You can download containers to run these sorts of things, and what it's doing is taking numbers and turning it into the ability to predict other numbers in the future. So this is a simple example. It's not magic, what we're doing here with machine learning. It's just extremely fast. Machine learning can find patterns. It can derive conclusions that we cannot see. As humans, we're just not capable of it. When you get into language and image recognition, of course, it gets more comprehensive, but that's a quick overview of machine learning with the simple goal of level setting where we are. And because of the math here, that's why AI and ML are such a perfect fit with DevOps and any form of IT ops. They're a great match together. So having level set what machine learning can and can't do and how good it is at certain things, that brings us to our next poll question. Help us understand the load that you are under today.
Thanks, Marco. So I found that pretty funny when the robot couldn't actually get into the door. That was pretty learning for myself. But yeah, so second poll question that we have, actually, this has to do with engineering burden. And so for the average engineer at your firm or yourself, what is the number of engineers to either servers or containers, depending what your topology is? What is your burden? Are you managing 1 to 100 or 1 to 1,000,000? Would love to hear what folks are managing today.
Yeah, we'll give the audience a couple of seconds here to submit their answer. And again, while we're waiting, just a reminder that the questions tab is open. If you do have a question for Marco or for Ravi at any time during the presentation, you can go ahead and just use the GoToWebinar control panel and submit your question. Also want to remind the audience also that we are going to be giving away the 3 $50 Amazon gift cards. So stick around until the end of today's presentation and we'll do that drawing as well. All right, we'll give you guys about 10 more seconds and then we'll close it out, and I will push out the results, and Ravi, you and Marco can discuss them.
Sure.
All right, I'm closing it out now. And the results, there they are. Looks Perfect. Like the majority are 1 to 100.
Yeah, and that makes sense, and that's what we're seeing in industry. Depending where we give the talk to, some of those numbers might be a little higher, but that's very telling of what's going on. As our industry moves forward, a lot of times we're seeing folks managing servers or containers in those upper numbers. So basically that means engineering burden is increasing. And so I want to actually talk about that we're all the captains of our own reliability. And what does this mean? As we start interacting and building platforms that folks depend on, as DevOps engineers, as SREs, and even as software engineers, we're actually in charge of the reliability of our platforms. And so I want to start with what is reliability engineering. So for folks who are unaware what an SRE or site reliability engineer does, SREs are in charge of having the ability to making sure that our systems are robust and has the ability to scale. And so really uptime, they focus on metrics such as SLIs and SLOs, and also the front line during an incident to bring our systems back up and running. These would be very important for the platforms that we work on. Google written the handbook on what a site reliability engineer is, but why don't we take a little bit of a look for something that has a little more gravity to it? What if there's a life and death situation? And actually, let's all become airline pilots. Let's actually fly a plane. Imagine this aircraft as our production system, and it is make or break every time we take off, take down, and touch down. So with this, pilots are a lot like engineers and a lot like SREs. Why is this the case? We can make a few analogies around this. Now, I actually really enjoy piloting and actually really enjoy aircraft, so some of my corny jokes might be lost. But if we actually take a step into a modern cockpit, the first thing you'll notice is that pilots actually have these really thick manuals called run books or checklists, which are synonymous with our standard operating procedures and operations. Now, these large run books have been replaced by iPads for the most part for weight savings. But basically what they do, they give you an idea of how to prioritize and also what steps to take if there's a problem. For example, if you lose an engine, or if there's smoke in the cabin, or a list of problems that you can face while flying an aircraft. It really helps you prioritize and also helps you make sure you're running in a proper specified order. Now, take another look at the cockpit here. As you see, there's a lot of, in a modern cockpit, this is a Boeing 787, and there's a lot of screens going on. So you're getting a lot of data thrown at you. Now, this can be synonymous with, I have a lot of systems I have to monitor, and that's what pilots are basically doing. But how do you actually increase the altitude of this aircraft? If I were to ask someone off the street, the natural affordance for this would be to actually pull back on the yoke. And I would think that too, but in a modern aircraft, how do you actually increase the altitude? Is actually this panel right here. This is the flight control panel. What the pilots are doing for the most part is actually entering the to-be altitude that they want to head to, and also the amount of increase and decrease that's acceptable. So you're actually using the autopilot to increase. This might be also, we're using, let's say, a container orchestrator in our systems like Kubernetes. We're specifying an end state. Basically, the pilots are specifying an end state because the machine, the aircraft, can react a lot quicker than the pilot themselves for these changes. Now, let's do a little bit of math. I wasn't very strong at math, but I'll try to do a little bit of basic math here. Going back to the quintessential problem with our algebra class, train A leaves the station at 70 miles an hour. Train B leaves the subsequent station at 80 miles an hour. If they were on a collision course, when would they actually collide, and how long would they take to collide? Now, when dealing with aircraft, actually aircrafts tend to fly a lot faster than 70 and 80 miles an hour. They're actually flying at 600 plus miles an hour. An important safety feature in modern aviation is something called TCAS, or the traffic avoidance system. And basically what TCAS does, it monitors the distance between aircrafts vertically and also horizontally. So if if two planes are going to collide with each other, the pilots will actually be getting alerts, aka called conflicts, to ascend or descend. And depending on how severe the alert is, how quickly do they have to ascend and descend? So again, at a 1,200 mile per hour trap speed, that's 600 miles an hour for train A, and 600 miles an hour for train B, the machine can definitely tell us that we're impending a potential collision. But since not all of us are pilots, and hopefully some of us have a car, if you take a look at a modern car today, I actually do have an Audi, it actually has Presense in it, is that when driving a car, the collision mitigation system in modern cars are there for just that. If there's an impending collision, my car will actually hit the brakes for me and actually bring me to a stop if I'm below a certain speed. Now, we can actually translate this to the platforms we work on, but being that if we're able to react quicker and actually avoid the conflict, isn't that just us reducing our mean time to resolution, or MTTR? This can translate into dollar amount savings and also avoiding a collision, which can be costly in an automobile or in a production system. So Marco, let's take our viewers out of the driver's seat or out of the pilot seat and take a look at the more human element of AIOps, which gets us into the second poll question.
Okay, the next poll question has been pushed out, and you can see it there on your screen.
So this one, hopefully a little bit simpler, but it's really just trying to identify. I'm going to spend the next few minutes talking about mean time to resolution. My background started as in operations. I sort of crossed the other way, whereas DevOps was often developers moving into operation functions. I came the other way from operations into development. And but this aspect of mean time to resolution was a key metric for the banks that I was working for back in Australia. So we're seeing some numbers coming in now. I'm seeing a reasonably interesting spread here in terms of the people, there's very few people who are saying that they have no way to measure the outage, which is good news, that you have systems in place of some form or another. And that's going to be great for you as you roll out AIOps to help the justification for AIOps and identify the benefit. So Charlene, are we ready to close out the poll?
Ready to close it out. I'm going to go ahead and close it and share the results, and there you go.
So fascinating here that the peak here is for the people are tracking it when it's a significant outage. So it's not necessarily an automated processing you're tracking. It's something that they're doing once they identify that they have a significant outage or anomaly. You're going to hear me talk about anomalies a bit. A bit of a shame. 18% are not sure of the accuracy of their MTTR. I'm actually a little surprised by that. And then you have about 1 in 5 who are basically, they don't have a way to measure it or they're not measuring at all. And as you introduce APM systems, application and other performance monitoring systems, of course, you will get metrics that will allow you to do this. So with that said, what I'd like to cover now is look, we're sort of about 20 minutes into the session. Let's start talking about what AIOps is. So I'm going to start with a quick definition. I could say, AIOps is AI applied to ops, but that doesn't really tell you much. So let's go with a formal definition here. What it does is AIOps augments technology to make things better. Now, what it's doing is taking things off the plate of the engineer. So to best understand that, let's look at how we measure engineering's reaction to anomalies and outages today. And for that, I need to deconstruct MTTR, the mean time to resolution. We're all familiar with using that as a single metric to track our ability. But what there really is here, there is really 4 stages that matter. Detection, the time between when things start to change and when we realize that we have an anomaly. To detect an anomaly, you need to have a clear definition of normal state. Defining normal was traditionally done by sort of manually defining thresholds and guesstimating what the thresholds might be of normal and then adjusting them over time. We don't need to do that anymore, and I'll go into that in a second. But detection is sort of the first place where time gets sucked in addressing anomalies and outages. The second one here is knowing or identification. This is the root cause analysis, the time to work out what's going on and where the root cause or multiple root causes are. A good way to think about this is to consider problem time on the left side of the screen here as the time when the anomaly or problem exists and you are not directly working on restoring the solution. We can just go back one for a second, Ravi. Sorry about that, I paused. With a known root cause, you can start working on the solution. But now you're transitioning into solution time, which you're seeing on the right side of the screen here. So the 2 aspects of solution time are fixing. That's when you actually started working on the problem. You're defining the changes required and you're deploying those changes. And then of course, verification. We have the time it takes to us to work out, did the fix actually solve the anomaly and that it didn't create new problems? So if you're a data-driven enterprise, you may want to start thinking about how you would track these. And from the prior question, it's clear that many of you already are. These sub-metrics, maybe you are, maybe you aren't, but this will give you a great before picture for AIOps so that you can measure the benefits as you roll out AIOps. So let's look at what AIOps actually does and how it impacts each of these 4 metrics: detect, know, fix, and verify. I'm going to start with detect. So knowing normal allows you to detect an anomaly. Makes sense, right? There are two ways we identify normal. One is historically, the 9 a.m. login storm, right? Everyone shows up at work at 9 a.m. and you get a login storm, everything sort of peaks for a bit, maybe response times drag for a little bit, and that's normal. The same thing happening at 3 o'clock on a Wednesday afternoon, well, that would be an anomaly. That could indicate that you had an outage and everybody had to log back in, or it could be an indicator of a denial of service attack coming into your environment. So understanding historically how data matches up to each other is critical. The second aspect of identifying normal that machine learning will pick out for you is contextual. These metrics generally track together, or these metrics generally track in opposition to each other. The threshold here is set to watch for the context changes, how they change in context with each other. So imagine trying to manually set a threshold for something like this, for context. So when metric 1 peaks and then metric 2 spikes, then metric 3 should spike at the same time, or else you have an anomaly. So writing that sort of code manually, or even identifying the metrics that track against each other is incredibly difficult and not suitable for humans, given the tens of thousands of metrics that we have in our environments today. So that's why machine learning is so cool in DevOps. This drudgery is done for you. The APM can identify and define normal out of the box. Now we'll look at correlation and how that works. So again, we're in detection mode here. We're identifying that you have an anomaly. So calculating normal is not just time of day, but also watching the metrics around the metric, the context. When we have these metrics tracked together, even if they change from historical norms, but they're tracking together, then life is good, and that's normal, that's fine. But what if that changes? So you look here, we see that network bandwidth and transactions per second are tracking together, and then they start to both go up together. Well, that's fine. They track together, they increase together, no challenge here. But if we watch it further through time, we see that the transactions per second continues to rise, and suddenly network bandwidth is flatlining, indicating that we've reached some constraint, and that's a problem. And that's why this, we see this as contextual misalignment. You have an anomaly, and you'll receive an alert. It would be a mistake to only think about system metrics here. And the key aspect of this is it's very clear as a human looking at these two particular charts. It's easy to go, oh yeah, at the end there, I see there's a problem. But when you have tens of thousands of metrics, you won't be able to identify the ones that you need to keep an eye on. You won't have it on the screen in front of you. And that's where the artificial intelligence, the machine learning, empowers the engineer to step away from the drudgery of monitoring. It would be a mistake, though, to think just of system metrics, as I say. We need to be able to detect business anomalies too. So in the example here, calculating normal is not just time of day, but watching the metrics around the metric. And we consider the scenario where everything in your environment, right, the servers, the application code, the databases are all under load, but just below normal threshold. The system will look green, as it does here on the screen, because everything is just below the threshold at its individual level. However, consider customer experience. The card transaction travels across each of these components, and instead of the usual sort of medium response time for each step, it's getting the maximum response time within range. All of those extra milliseconds add up, and the business transaction that the customer experiences is actually so slow that they're abandoning cards. A system metric will not tell you this, but you need to be measuring the overall business transaction as well. When we look at the business transaction, we see the total sales and the orders placed, they're highlighting in red. So we're not just looking at systems here, we're looking at the business as well. Seeing it from the business side will detect those obscure anomalies that can poison applications. So don't forget that when you're feeding the data into your APM system, that you need to be tracking business information as well. So after this, AIOps is minimizing that detect time part, that portion of MTTR. And you already have the normal state defined, so we can easily verify, and we're minimizing the verified time as well. But what about that time to identify, the no time? Think of the steps that go into root cause analysis normally. You'll start up a war room. Well, first you'll get every man and their dog in the war room because you're not sure where the problem is at this stage. You start to create a timeline. And then people are doing log dives, you're running scripts to try and pull metrics out, you're processing those metrics, right? Or because to get to the point of going, well, we think the problem is here. The beauty, again, of AIOps is that it's analyzing those metrics the moment an anomaly starts. It creates the timeline for you. You see an example across the top of the screen here. We're initializing a timeline. And AIOps gets you to that root cause directly. And it's even better that, you know, if it's a brand new problem that you've never seen before, then the root cause may not be just a single thing. And it will present probabilities of where the root cause is. In this case, payment service and order service are the things where it has calculated the probabilities of where the root cause is. So now you have knowledge of where you're going to fix things. So all of this comes from simply turning on AIOps. And by doing so, we go from this, where we had significant problem time, significant solution time, to this, where you have AIOps time. You're immediately knowing that there's an anomaly in existence. And remember, an anomaly may not be an outage. It might be just something that's beginning to happen that is predicted to happen. And we get to this, we'll get to full automation in a moment, but simply reducing this amount of time is not enough. Things are still happening in silos. So let's talk about where we get real value from AIOps. And that comes from constructing, you know, our vision of AIOps, of constructing a central nervous system. So to make this match the wider world of AIOps, I'm going to move from the terms we were just using, MTTR terms, detect, knowledge, fix, and so on, to new phrases. We'll talk about visibility, insight, action, and the feedback loop. We're expanding here from IT Ops and DevOps to AIOps. Here at AppDynamics, we started with application and business monitoring, and we are now helping businesses apply artificial intelligence and machine learning to enhance IT operations. Building off that, our vision is to expand the same capabilities that were built around application and business transactions across multiple domains. You may know 2 years ago we were acquired by Cisco. We're now part of Cisco, and we have a broader visibility into those domains now with the enterprise needs that only Cisco and AppDynamics can provide. Similar to how a central nervous system in your body takes input from all of your senses and coordinates action throughout the human body. Well, our AI strategy is to deliver the central nervous system for IT operations. AppDynamics started this with applications, but we're adding in infrastructure, networking, security to provide the information you need, and of course, third-party from the information from the existing systems you have to give even richer visibility of the overall environment. And of course, through the machine learning algorithms and our teams of data scientists who are calculating and rebuilding those algorithms, the insight to track back the root cause and to identify where you need to be addressing the fix. So simply by turning on AIOps and our cognitive engine, you're addressing that mean time to resolution for anomalies and outages. As you can see, it's revealing aspects of your applications that you were perhaps not aware of, and you realize how accurate the root cause analysis can be. You will be wanting to automate more of the repetitive actions. This is important from a technology and from a human point of view, so that we take the stress away from being an engineer in the modern DevOps world. So let's take time to examine actions here. The next step of taking the action on the insights we derived to remediate problems. We can prevent issues before they happen, before the customer even knows about it, and we can optimize the operating environment. So as we discussed, we're integrating with actioning systems for incident response and workload and container orchestration, cloud cost optimization, network automation, and even security enforcement. These integrations connect around this intelligence that we have identified and created in the middle of our APM system. With machine learning, these actions will continuously adapt to the changing business conditions. You get more customers, the thresholds adapt automatically. In the world of AIOps, every customer can move at their own pace. So with that, Ravi, I'm going to ask you, how should engineers be thinking about their role in this AIOps environment?
Oh, absolutely. With AIOps, it's really we're getting a helping hand from the machines, right? So really we're enhancing ourselves to help us focus on what's making us value, what's making us innovation, and really subtracting from what I like to call the complex mundane. So basically what Marco and I have been talking about for the last 30 minutes is when looking at this from a development or operations side, is that what we're getting is an assistance or aids. Now, with particular these assistants or these virtual aids that we have here, is that we're all human, right? So we can't subtract the human element out of our systems. We might be on projects for a short period of time. The learnings from team to team, as good as we might document them, but we can actually start providing systematic documentation with AIOps. And basically what this means is we're providing guardrails. So just imagine yourself as like maybe a first-time engineer on a project, or you just started, or a major change went through. How do you know how much of a change to make, right? Like if you're tuning a particular container orchestrator, how do you know how much, let's say, CPU or memory or storage to tune the container space with to actually make sure you're not impacting the system? And those type of guardrails are very important to learn, but also you have to learn them, right? What if the system can do it for you? One of the main benefits also of AIOps is actually the ability to auto-tune. If we take a look at cars of 50 or 60 years ago, there was planned obsolescence. You would buy a car and you would just throw it away and get something else. Now today, we actually take care of our cars because they're quite expensive. If you look at the total amount of IT spend in the SDLC or software development lifecycle, a majority of that money actually goes towards maintenance. What if we had the capabilities of actually auto-tuning our applications? And that's not so far-fetched with AIOps. Since the system's always learning and always watching, potentially you have the ability with using a container orchestrator such as Kubernetes or Mesos to actually give those tunes for us. Going back to our visibility, insight, and action, imagine that the AIOps system provided by AppDynamics is always watching and always providing intelligence. And so interacting with your container orchestrator and providing you with decisions, even on your behalf, automated or autonomous decisions by correlating performance and other metrics to actually take action with the container orchestrator to maybe redeploy another version of the app or actually give some more tunings. If memory pressure is too high, maybe increasing the amount of memory the container has, or redeploying another version of the application. And really having this in the feedback loop, doing things and also alerting the operator that these things have happened can actually make you rest easy at night that the system is taking autonomous action for you. But what does this actually mean, and where has this been done before as a coaching tool? So my background actually comes from application development. And a tool that come to mind for myself is called Sonarqube. For those who on the webinar who are not familiar with what Sonarqube is a code coverage tool. It actually scores you what you're doing. I used to get pretty bad scores. I used to get a C- or D. I would say C's and D's make applications to my team lead, and he would get really mad. But that's really what it was doing. Like we have to ship it one day, so we need to get it out. Basically, I used to think Sonarqube was the enemy, but actually what Sonarqube was, it was actually helping me, teaching me to become a better developer. Sure, there were some stylistic changes I could make, which I actually make today as a more senior engineer, or also even things that I'm unknowingly doing. I might be including an old version of a particular package, and Sonarqube would tell me that, hey, this package version might have a vulnerability. So really helping me teach me systematically to become a better engineer. And also with that, it's just the knowledge of how the application is. One of the hardest things also for me as a development or a software engineer, and when dealing with a production issue, is like, hey, what was normal before? Like I made a change, but are we really having a decrease in performance, or is this really that far off? It's a feature, not a bug, right? As the going joke would say. But having contextual data, a recent Stack Overflow survey is that looking at the 2018 historical survey is that it shows that people are spending less and less time on projects and more time to get ramped up. With that, the amount of usable time as an engineer is going down. Here, I can take a historical look at 6 months, and this might be the entire time of my useful time on a particular project to take a look at what a normal baseline is. And this is substantial. I can take a look back in the past and taking a look at, hey, this is what we need to automate, and this is historically what was going on, which is totally fantastic. But how do we start getting these capabilities, and what does it look like for us to actually start implementing AIOps in our organizations? With that, I'll kick off one more polling question for you, which quote best matches your organization today before we start getting into automation?
So we'll leave the poll question up there, and I'll just talk a little bit about it. But the essential idea is, with this one is, which quote matches you better? Which would you be most comfortable saying about your enterprise environment today? Are you somebody who just reacts that things go wrong, and then when they go wrong, you address them? Maybe you're a little bit proactive, that when something goes wrong, after you've fixed it, you might have a post-mortem to work out what went wrong and perhaps try and put something in place to prevent it happening again. Or are you at the stage where you're actually using data to go, where you're predicting imminent events, where you're starting to tie together that, indicators that you've seen previously. So before it even goes wrong, you're starting to take action, but you're still kind of reacting to that predictive ability. Or are you through all of those phases and you're actually in the preemption world, the sort of Nirvana of preemption, where no, you're just really focusing on making sure you build the environment that works the first time, because you have the time to do that. And this is the great challenge. I mean, Ravi, your point about the ramp up is classic. We've all stepped into responsibility for a new application, and the amount of time it takes you to just work out what the dependencies are and where things are stored and what sort of code system is used in this enterprise. They're all the challenges we face. So which of these do you see yourself at today? Okay. So we've got some good data coming in. So Charlene, maybe we can push that out.
Absolutely. I'll close out the poll now and share the results.
So again, this is what I hear when I'm sort of sitting down having conversations one-on-one with people around the country and across Europe. The bulk of people, they're proactively learning. So, once something goes wrong, they fix it, and then they'll have a post-mortem to try and make sure it doesn't happen again. This is, has been a traditional way, but it's not where we need to be today, and it's not where we have to be today. We should have these mechanisms, as humans, we couldn't possibly predict the things based on the metrics and the vast quantity of metrics that we have. But now we have tools that can help us be better at this, that free us up to focus on preemptive. So let's talk a little bit about that. So hopefully by now, after everything we've talked through and the reduction of MTTR and so on, you're starting to visualize and think about how you would apply AIOps in your environment. And at the end, I'll share some links on reading if you want to read more on the topic of deploying AIOps successfully. This is an easy approach, and it just helps you get in the mindset of where automation adds value and where it subtracts value. Release engineers have been automating builds and testing for over a decade, but some major resolution tasks like a rebuild of a database or a recovery might be, they might not be suitable for full automation. So I worked out 5 criteria that I use when I'm consulting with clients of how to decide what to automate. The first one is pretty easy: frequency. How often does it happen? If this is a one-off and it never happened before, and you look at it and you think that's unlikely to ever happen again, well, that doesn't warrant automation. This is where and by the way, this is where you want to look for the query language in your APM metrics so that you can go back, because once you know what the anomaly looks like, you can query to find out how often it occurs, and even search for times you came close to an anomaly in the past. Because again, when something finally comes to your attention, when it finally breaks, it's often just the final straw in a series of events. So frequency is the first metric that you want to look at and score. Next, we want to talk about the impact. Are you automating the solution to a major issue? If it's something that in your overall enterprise, it's really just a drop in the ocean, in terms of the effort involved and so on, then, automation isn't the go. If it's just a temporary slowdown, automation is not the go. So you've got to ask yourself, what is the cost to the business? But if it's a, dinosaur finishing sort of earth impact, then these are the things that you need to automate so that customers don't even experience them. They're fixed before a customer is even aware of it. And that's where tracking business transactions will enable you to correlate that business impact to the organizational value. The third one here is coverage, the proportion of the real world process that gets covered by the automation. If the task requires a manual step in the middle, like unplugging a cable or something, or you have to contact your cloud provider, then automating the other parts may not be that helpful. But if it's something that you can go, yeah, we can cover the entire resolution here. And I think of simple things like bouncing up networks bandwidth or something like that, then obviously automation is easy and it covers the entire solution. The fourth one here is probability. I love my XKCD cartoons. The probability of successful automation. This is about the accuracy of the procedure. Are you sure that running this procedure will happen in the same way each time and will successfully automate the resolution each time? Now, again, these are estimates, these are calculations that you have to make. What I do when I'm working with clients is I assign scores to each of these, and then at the end you have an overall score that indicates whether something should be automated or it's not worth it. Because remember, as you automate, you're creating technical debt. That automation has to be kept up to date whenever you update the systems that it's automating. If it impacts network and you change your networking vendor, you have to update the automation and scripts around it. So that's why there is an assessment of what you automate and what you don't. The fifth category or characteristic here is latency, how quickly the steps will execute. You may not want to automatically begin a multi-hour database rebuild or a database backup and recovery. Momentary adjustments, like examples in Kubernetes coverage and so on, well, they'll sort of boosting network bandwidth. They're perfect for automatic reactions. The anomaly will be resolved before a human could even have typed in the commands manually. And that's a very clear one. If it's happening often and it can be automated faster than you can type in the commands, obviously you want to automate that. So there's 5 criteria that you can use and should use to select what to automate. And as we're doing all that, remember what your goal is here. We asked the poll question and we saw, for most of you, that you're in the sort of first step towards Operation Nirvana. You're in the reactive mode. Well, in fact, most of you are in the proactive state, which is excellent. But there's a journey ahead of you of moving towards predictive so that you can use data to predict and respond to imminent events before it becomes an anomaly. And finally, preemptive, where you're using the data instead to actually continually optimize the outcomes. You're focused on the delivery portion of it rather than the systematic portion of it. In DevOps, we're always on a journey from basic system management scripts through application performance monitoring. And then we added in business transaction monitoring, and we moved from systems to virtual machines to containers to serverless. We're always on this journey, and the need for operational management is only getting more complex and onerous. You need to be an agent of transformation in your organization. You will move to include AI and ML in DevOps, not because it's fun, which it is, by the way, but because it's necessary for you to survive the next phase of operations. So, okay, we've shared a lot with you in the last 45 minutes. Let's look at a few quick takeaways here.
Absolutely. From my poll question, this actually is really true. The engineering burden is only increasing. It showed that most folks on the phone were averaging about 1,000 servers or containers per engineer. But as I talk to more and more people in the field, that number is actually increasing. And without the automating and having intelligent automation, it'll be extremely difficult for us to maintain those particular numbers of servers or containers without AIOps.
And the point that we're trying to get across here is that AIOps is different. It offers immediate relief. Now, if you've got gray hair like me, you might have experienced prior sort of automation of operations where you had to do an enormous amount of work before it ever delivered any benefit. You had to set all the thresholds and define everything. The beauty of machine learning, the reason I'm so excited about machine learning here is that you don't need to do that. What you do need to do to get the full value is update your mindset. You have to think about prediction versus reaction. You have to think about answers over investigation and actions over analysis. So if you're the Sherlock Holmes type that used to love digging through the logs and working out where the issue was, this is bad news. But if you're the person who loves to take action to actually fix an issue and to spend your time on, as I say, preemptive work, then this is great news. And by the way, it's better with cross-domain. The intelligence, the way machine learning works, as you throw more metrics into it, more instances of data, there is a cutoff point where it stops getting better and it just takes longer to train the model. However, as you include more features, if you remember, they're the columns in our data set, as you add more features that correlate to the target to the outcome that you're looking for, then it gets better. And that includes cross-domain information across, application to networking to servers to serverless to cloud. And it also includes the business transaction. So don't forget to include that.
And one of the big takeaways for me is this automating what I like to call the complex and mundane. The complex and mundane tasks are the most frustrating tasks, in my opinion. They take away from core innovation work, and also they're fairly complicated. So there's a lot of room for error, and they're not very fun because they're mundane, such as scaling a cluster. Well, that's complex and it's mundane because it needs to happen. By taking away those complex and mundane tasks, we're really augmenting ourselves or augmenting yourself as an engineer. We're able to focus more on what's providing value for our organizations and enterprises. And two, we're able to pick up new skills maybe because the system can teach us, right? So if you're trying to learn different types of skill sets, taking a look at the learnings that an AIOps systems can teach you. Remember Sonarqube teaching me better code syntax. It's really there to help. And now we do have a few resources, and with that, let's share a few resources that we do have. You can actually email Marco and I if you want to get a copy of the presentation at evangelism@appdynamics.com. Just email will go to both of us, and we'll be happy to take questions or communicate with you via email. Also, there's a few pieces that we do have here. So we talk about how AIOps plays into self-healing infrastructure, the AppDynamics vision for AIOps, and also what the staffing for this would look like in the future. So we have a lot of great resources here at AppDynamics to really get you educated and get you ready for the AIOps revolution. With that.
All right. Great. So we do have a couple questions that have come in so far, and so I do want to dive right into that. But if you do have a question, please, it's not too late. You can go ahead and use the GoToWebinar control panel and submit your questions, and then whatever we don't get to during the Q&A session, the folks at AppDynamics will be getting a copy of all the questions. So I'm sure you'll be able to get your question followed up afterwards. So let's dive right on in here. We do have one great question.
I'm sorry to interrupt there, Charlene.
Yeah.
Ravi, do you want to just go back one, because the slide wasn't up long enough for me to write down any of those links?
We'll keep it up for us to take up questions. So if folks want to get contact us.
I just like looking at Link at the same time. He makes me happy.
All right.
Very good character.
Excellent, excellent. All right. So first question: with technology upgrades coming so fast, how feasible is it to get used to these new features before something new comes? By the time you implement one, there is something else new. So how do you address these type of questions or scenarios? It seems like we're moving so fast.
Mark, you want to take that one?
So I'll go first. So the simple thing is, that's what we're trying to address. So in terms of learning the new feature, I don't know if it's a new framework that you need to develop your application. This won't help with that, but here's what it will help with. How that framework works in your application. You can run APM, you can run AIOps against your development pipeline, so that you will see, as soon as you embed that framework, you will see the impact on your environment straight away before it's even gone to production. And that's the aspect here of the machine will learn. You don't have to set thresholds anymore. You don't have to understand what it looks like. The machine will learn that as it retrains the model with fresh data. So as you put that framework into the AIOps environment, the machine learning will train off that data and change the thresholds. In this example, that definition of normal. It will change that definition. I can't even get the word out. It will change that definition of normal to match what the new normal is. So yes, you might still have to learn what the feature is from some point of view, but you won't have to learn how it runs. And we're taking that away from you. That fog of development is getting lifted so that you can focus on, how to exploit the feature in your environment, rather than, how does it change the other things running in the application. Ravi, any thoughts on that?
Yeah, absolutely. Like as we look at the technology curve, that's basically it, right? We're really battling that. The going joke I like to tell people: if you go to buy an O'Reilly book, out of 700 pages with a funny animal on the front, it's the first 30 pages are really development-centric stuff. How do I do a basic CRUD operation? on, let's say, a different type of message broker or a different type of technology. The other 670 pages are operational excellence, the really, really hard parts. So with AIOps, going back to if it's a new framework or a new particular design pattern, the system is providing us more learning with that, right? So it's helping us reduce the amount of those 670 pages that we need to read. Because as we know, our platforms are becoming more distributed and we're including more and more packages. Our applications and platforms are becoming more complex and more for us to learn. With the system to help us, it's a great way to learn and beat the curve.
All right, great. I think we have time for one more. So how do you identify the features to consider for machine learning? Can you do this interactively, adding and removing them to optimize the balance between training time and insight?
That's a great question. So, and the short answer is that in generalized machine learning, if you're doing all of this yourself, then yes, you can do that, and you would have to do that, and you're going to try it against different features, and it's time consuming and everything. The whole way that at AppDynamics that we developed, we acquired a company called Speaker, which gave us a room full of data scientists. They're continually reworking the algorithms for you. So the beauty of this is that you don't need to do this. This is built into the APM solution. And you turn it on and it starts working straight away. The baselining of normal and verification that I talked about, that's been in the product for some time now. And then the additional piece of the root cause analysis, we're running to select customers in the moment, and that is, but that is in the product today. The beauty of this is that you don't have to decide which features to track. You load the data in, and our algorithms work that out for you. That's why I'm so excited about this. Like, I do love machine learning, and yes, I do run TensorFlow on the weekend for fun, and run my own photo image recognition things. Machine learning is fun, so yeah, if you want to do it, you can do it, but that's not what we're talking about here. What we're talking about is the benefit of this, that these things are built into the system for you so that you can move on. And as I say, focus not about, how machine learning actually works, but focus instead on this is how your operational environment works. This is how you're going to architect it, how you can preempt and become preemptive in your environment.
All right, great. Well, we are about 3 minutes to the top of the hour, so unfortunately I do have to close out the question and answer period. It was a short one today, and like I said, I know you're having fun.
Oh, we love questions.
Well, maybe you guys can have a question and answer party later on or something. I'm not sure.
Sure.
So as I said before, if we didn't get to your question, I apologize, but the folks at AppDynamics do get a copy of all the questions, so I'm sure they'll be more than happy to follow up with you after the event. And before we close things out, I do want to do our drawing for our 3 $50 Amazon gift card winners. So without further ado, our first lucky winner today is Ben Gilbert. Congratulations, Ben. Our second winner today is John Domini, I think it is. So congratulations, John. And our final winner today is Presidio Calumpit. Congratulations, Presidio. Congratulations to all three of you for winning. Yeah. So hooray, hooray. So I guess,
don't spend it all at one place.
Exactly. Well, they kind of have to because it's Amazon. So anyway, I do want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, because we had such a great time today, just you will be able to listen to it on demand. So just look in your email. There should be a message coming forth soon that will contain a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website. So if you want, you can always just go over to the DevOps.com website /webinars. Look for it there. It should be right there waiting for you. And while you're there, please take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Ravi and Marco, thank you very much for giving such a great presentation. Lots of interesting stuff in today's webinar. I appreciate it. I know the audience did, judging from the number of questions we got.
Well, thank you very much.
Excellent, excellent. Well, this is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.
Cheers, everyone.
Cheers, folks.